Inverter or NOT gate. Let's kick things off with the simplest gate, the inverter or the NOT gate. The NOT gate serves as a complement to a digital signal. It inverts the input signal, meaning it outputs the opposite value, and it has only one output. But before we dive into how the NOT gate works, there are three essential components you need to understand when expressing any gate. First, the symbol. This is the visual representation of the gate. It's like a logo that tells us what kind of gate we are dealing with. Second is the Boolean expression. This is the mathematical way to describe the gate's function. It shows the relationship between the inputs and the output. And third, the truth table. This table lists all possible input combinations and the corresponding outputs. It's a way to show the behavior of the gate in every scenario. Let's now take a closer look at the NOT gate symbol, Boolean expression, and truth table. The NOT gate symbol is a triangle with a small circle at the output, indicating inversion. And the input is labeled as A and the output is labeled as X. For the NOT gate Boolean expression, it is X equals to not A with overline A. This means the output X is the opposite of the input. For the NOT gate truth table, we only need one input, and the table shows that if the input A is 0, the output X is 1, and if the input A is 1, the output X is 0. This shows that an inverter provides the complement or inverse of its input signal. OR logic gate. The OR gate is one of the most commonly used gates in digital electronics. It can have two or more inputs with 2 to the power of n possible input combinations, where n is equals to the number of input bits. The operation for OR gates is addition, or the plus symbol. Output terminal X is high whenever input A and B are high, or both inputs are high. Now let's look at the symbol. The OR gate is represented by this shape, which is a curved pointed symbol. This shape visually indicates that the OR gate's output X is high if at least one of the inputs, either A or B, is high. The Boolean expression for the OR gate is simply X equals to A plus B. Here, the plus or addition sign represents the logical addition or operation between the two inputs A and B. Now let's take a look at the truth table. Knowing the number of inputs n equals to 2, hence the possible combination is 2 to the power of 2, which is equals to 4, giving 4 possible combinations. The truth table shows all the possible input combinations and their corresponding outputs. When both inputs A and B are 0, the output X will be 0. When input A is 0 and input B is 1, the output X will be 1. When input A is 1, the input B is 0, the output X will be 1. And finally, when both inputs are 1, the output X will be 1. In simple terms, the OR gate outputs a 1 whenever at least one of the inputs is a 1, and it only outputs a 0 when both inputs are 0. This gate is particularly useful in scenarios where you want an action to be triggered if one or more conditions are met. For example, in a security system, an alarm might go off if either a door or a window is open, which can be modeled using an OR gate. Now that we understand how the OR gate works, let's move on to the next gate.